Don't hang up that phone. We've found what you're looking for. Welcome to the Let's Talk Cabling Podcast with Chuck Bowser, RCDD. Well, seeing how we're pulling Category 6A, the most powerful twisted pair in the world, you gotta ask yourself this one question. Did I pull 295 or 300 feet? Well, do you feel lucky? Do you, punk? What exactly does RCDD stand for? Registered Communications Distribution Designer. Just the expert you need to ensure your cable plant performs exactly as designed. The elite professional, knowledgeable, and experienced in leading-edge ICT design principles. Now, send the new guy to the truck.
There we go. It helps when you turn the microphone on. Holy smokes. Oh, my Lord. You ever have one of those days where just nothing went right? That's today. That's today. As I was saying, I went to the eye doctor today for a follow-up visit. And I have to wear those funky glasses. These are these glasses I just showed you because they dilated my eyes. and I'm really sensitive to light, so I got to wear these funky glasses. So ACR-F, what does that mean? Tell us in the chat box. It has something to do with tonight's show. So I'll give you a few. It's like, look at that. Somebody's already got it right out of the gate. Bob Eskew, attenuation crosstalk ratio far end. Nice. Excellent. Good job, by the way. That was it. So yeah, that's it. So, all right, let's go ahead and close down the challenge there. Sorry, it's hard for me to really, since they dilated my eyes for the eye exam today, because again, they're following up my eyes because of my eye injury. They dilated. I can't see anything. I can't see anything on the screen. Let's see. There we go. There it is. Turn it off. Yay! There we go. So for my peeps on LinkedIn and YouTube stuff, here's my funky glasses I'm supposed to be wearing. Yeah, don't I look cool? Yeah, you can say it. Really cool data dude. Yeah, that's me. That's not what RCDD stands for. Anyways, did you catch last week's show? Let me know if you liked it. I did a show on what is a structured cable system. So Anthony's in the house. Hello, Anthony. What are you drinking, my friend? So I did a show on structured cable systems this week on the podcast. I talked about subsystem 1, subsystem 2, subsystem 3. I covered what it was an HC, an IC, and an MC. Wise components in the house. I even talked about the differences between permanent link and channel in that episode. It was a great episode. Let me know if you want me to do more content. Like I know I've been doing a lot of interviews lately, but a lot of people come to me with some great stuff that they want to bring on or have me discuss on the show. So if you want more shows like that, let me know and I'll definitely put that up in the thing. So last week's live stream, which was on Thursday night, we covered what causes wire map fails. We covered what causes length fails. We covered what causes near end crosstalk, far end crosstalk, power sum near end crosstalk, power sum far end crosstalk. We covered all of those. This week, we're going to cover what is return loss, what is attenuation crosstalk ratio far end, power sum attenuation crosstalk ratio far end, and insertion loss. So I don't know if today's show will actually go the full 30 minutes. So if you have a question, make sure you put it in the comments too. So that way, if I do run out of time, we can cover that. Right. So there's take these notes. Hopefully, I don't lose my power. I hear it thundering outside, and whenever it thunders where I live, it means you're going to lose power. And if I lose power, live stream's done. Mm-hmm. Again, I'm drinking half cut tea. So let me flip over to my notes. So last week we covered near and crosstalk, far and crosstalk, power sum, near and crosstalk, power sum, far and crosstalk. So let's talk this week. First, we'll cover off with insertion loss. What is insertion loss? We used to call it attenuation. And that's what that's how much the signal gets weaker as it goes down the cable pathway, right? So it's a very, very critical function. There are several things that can cause high insertion loss limits. Let's go with probably the most common. The most common is your cable's too long. You heard me right. Your cable is too long. Now, I know the standard says 295 feet, plus or minus 10%. So you can literally go a little bit over 295 feet. I understand that. But when we as technicians, as installers, we like to leave coils in the ceiling. So that way, if a drop moves, we have some slack for it. So excessive length, usually the biggest cause is you coil it up too much in the ceiling. And when you combine that coil in the ceiling with the length of the cable, you're now over length. So whenever you're pulling cables, especially if your cables are over 150 feet, right? Even though we can go to 295, when over 150 feet, start paying attention to your coils, right? That can cause that. Also, you might have it just because it's too long period without the coil. Because there are some customers that will try to, to minimize the number of telecom rooms they're going to build. So that way they don't have to pay for excess telecom rooms. So they'll try to get some really long runs out of the rooms. Well, again, as soon as you go past that 295 feet, you're gambling right now. You might as well go to the casino because you might work, it might not work. So excessive length. If you have a cable that's going to get, you should do this every cable. And I think I said it last week, and if not, I'll say it again because it bears repeating twice. Your number one job as an installer while you are installing cable is to keep that cable from getting kinked, crushed, stepped on, cut, burnt, or painted. Okay. The more that cable is like it is the way it came from the factory, the better chances it's going to perform the way it was designed. So if you have a cable with none of those issues going on, it'll probably actually work past a little bit past 295. I wouldn't bank on it, but it might. If you have a cable that's 290 feet long, so it's 5 feet shorter than what the permanent link allows. Daryl, the RCDD is in the house. So if it's 290 feet, so it's 5 feet less, but you got some kinks in that cable, or you damaged the cable because you pulled around a corner, you've damaged the cable, that could cause you to have issues, right? Another thing that could cause insertion loss, poor quality patch cords. Poor quality patch cords. So always try to buy quality patch cords. Buy them from reputable manufacturers. You could probably think of 3 or 4 good manufacturers. Matter of fact, in the chat box, tell me whose patch cords do you like to buy? Whose patch cords do you like to use? So put that in the chat box. So use good quality, because using a poor quality patch cord could cause you to have high insertion loss. The next thing is you selected the wrong test in the tester. You're testing Cat 6 cable, but you forgot to change it off 5E. That'll cause it. That's why it's really critical to have some kind of a standardized testing plan. When you get that tester out on the job site, what is the process? Maybe even have a checklist. An airline pilot flies hundreds of hours, thousands of hours. But what do they do every single time they sit down in a cockpit before they take off? They've got a checklist, and they go through the checklist, right? So do the same thing with a training plan. Go through it and, hey, what's up? Go through the checklist. Did you put the right name, the person's name who's actually doing the testing? Did you put the right project name? Is the tester set up correctly? Are you doing the correct kind of test? Does the customer want permanent link test or channel test? Right? And then also make sure that you have it set up correctly. Is it set up for Cat 5e, Cat 6, Cat 6a? That'll help eliminate that incorrect test selection that could cause you high insertion loss. Another problem is you could actually have an inappropriate cable category in your channel, meaning you might have let's say you got you're testing it for Cat 6, and then you got somewhere in there you have a Cat 5e patch cord or a Cat 5e cable. That could cause high insertion loss as well. Somebody says in the TikTok chat box, "Hey Chuck, just got my Fluke Network Copper Test certification. Nice. Gonna write the fiber testing next week." So did you take the class with Mike Pinocchi? Let me know, yes or no. Did you take the class with Mike Pinocchi? Mike is a really, really good instructor. I've had him on the show several times. He's a great guy. So another issue you can have with high insertion loss is, and this one's is not it will show its ugly head. And let me put it this way. In my 42-year career, I've only had to deal with this twice. So again, it's not something that happens all the time. But remember, if you got that checklist, then if it's not the most common thing, excessive length, then you can go right down this list. Hey, maybe I should turn these last 2 shows into a checklist. Let me know in the chat box if you want me to change this and put these 2 shows into a checklist so you can go through and you can verify that everything was checked. Let me know. That'd be cool, right? So yeah, this one here is inappropriate pulling lubricant. And I would add to that also the cable's too wet. I'll add both of those. You see, a lot of people don't realize pulling lubricant is 97% water, 3% solid. So you're literally putting water on the cable. If you put too much lubricant on the cable, you will fail because of insertion loss. Now, the good thing is, my Fluke guy who just took his copper certification test will tell you, You can go into the TDR, the TDR functionality of the tester, and actually pinpoint where that moisture is, right? So too much lubricant, and next time you pull a cable, that you're putting lubricant on, do this simple test. After you get done pulling the cable, test it. Do a certification test, not a qualification test. Do a certification test. Save that test result. And then at the end of the project, test it again, and then compare those two values. You'll notice that the insertion loss values will drop as the cable lubricant dries out. Somebody says, no, you won't. No, I won't what? We had cable fails because the ambient temperature was about 5 degrees Fahrenheit. Oh, that's actually a great one, Daryl. Oh, that's a great one. And you know what? It's not even on my list. That's why I like having fellow RCDDs in the room. So Daryl, the RCDD, a friend of mine who is up in the Virginia area, he also pointed out that high insertion loss could be because of excessive heat, right? And it's a true statement, especially if you're running cables in warehouse. A lot of times in warehouse, we like to run the cables up high in the red iron. And when we do that, we're putting it near the ceiling. And the ceiling gets pretty stinking hot. And also heat rises. I actually had some cables run through. I don't believe lubricant can cause insertion loss. Oh, yes, it can. Seen it. So there you go. Absolutely test it. Absolutely test it. Too much cable lubricant can cause an insertion loss failure. It's been done many times. So yeah, high heat will do it as well. So, if you're putting cable in a warehouse, maybe not put it right up next to the very top of the ceiling. Maybe put it at the bottom of the red iron, or maybe attach it to the walls and come down a little bit further to get it out of that heat. So that's a great way to have that problem, have that cause a problem for you. All righty. So we did insertion loss. Let's see. What is the next one? Trying to get my nose to come up here. Man, I tell you, since they dilated my eyes because of that exam, it really, really, really is causing me problems. Bum, 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 bum. Here, let's do this. Let's take this to full screen. There we go. So maybe I can read it. Yep. All righty. So that was insertion loss. Then you have ACR-F and power sum ACR-F, right? Those are usually connected. What would you want me to test? Yellow 77. Yellow 77 is not designed for high performance data cabling. It's really designed for outside plant cabling. You're supposed to use, for high performance data cabling, you're supposed to use Polywater or Clear Glide. It's funny you mention it because I have a friend over at Polywater. They sent me a 5-gallon bucket of pulling lubricant, and I got some cables, and I'm going to put it in there, and I'm going to test it with my certifier. So that's actually coming up on the show. Says the industry, says Fluke, says AEM, Softing. All of them will tell you that. Too much pulling lubricant. I'm not saying pulling lubricant itself will cause it. Too much pulling lubricant can cause it to fail. So there you go. So attenuation crosstalk ratio far end, power sum attenuation crosstalk ratio far end. Those are functions typically associated with near end crosstalk, far end crosstalk, and stuff like that. So if you're getting those kinds of fails, you're also getting fails in near end crosstalk, far end crosstalk, and the power sum crosstalks. So if you have those kinds of issues, make sure that you go up to the near crosstalk and you use those issues to solve that I talked about earlier, right? So that'll solve those issues, because the service loops, and here's one thing that caused a lot of those for the attenuation crosstalk ratio far end and the power sum attenuation crosstalk ratio far end. Service loops too tight, or combine that with excessive length. See, when you coil the cable into a nice tight little coil, that creates an inductive loop, and that could cause problems, right? That could cause you all kinds of problems. So watch out for that. All righty. Why is my notes not coming up here? There we go. Oh, come on, dang it. Don't you hate when things just don't go the way they're supposed to? Isn't that a pain in the neck? Let's try this. Do that, and then come back to this. And it just disappeared on me. Wonderful. There we go. There we go. Here we come to save the day. Hey, hey, let me know if you know where that comes from. Yes. Let's just. All right, you can make me do this. I'm breaking out the old man glasses so I can read these notes. I don't like doing this, but again, with a doctor's appointment, all that other fun stuff. All righty, so return loss. What is return loss? So the characteristic impedance for 4-pair UTP cable is 100 ohms. 100 ohms. I usually have a piece of cable sticking. Here we go. So the characteristic piece for the cable is 100 ohms, plus or minus 5%. So literally, this cable might be 101 ohms. The characteristic impedance for a connector is 100 ohms, plus or minus 5%. So as that signal is coming down the cable's 99 ohms, the connector might be 101 ohms. Because of that little bit of a mismatch of characteristic impedance, it's going to cause some of the energy to get reflected back towards the transmitter. Okay, back towards the transmitter. In that scenario, you want a small dB number. I'll explain what a dB number was in the last week's live stream. So that's what we're talking about. Matter of fact, the closer those two numbers are to each other, the more energy goes through that connection point. That's why many of the manufacturers, connectivity manufacturers, that's why many of them will literally, because they don't make cable, they'll go into a partnership with a company that does make cable, and they want to make sure that their cables and their connectors are a matched system, right? So return loss is how much energy gets back. So what causes return loss, right? High return loss issues. One, I'll go through probably the most common. Do you do a lot of alien crosstalk testing in the States? Great question. No, we don't. Do you do a lot of alien crosstalk testing in your country? And what country are you from? Anthony, I see your question, but I'm going to have to answer that later. Just so you know, I'm not ignoring you, my friend. So usually return loss, the number one issue I think I've come across is, sorry, from Canada. Yeah, exactly. Alien crosstalk testing is actually not required by the standards, by the way. So getting back to return loss, too much untwisting or kinks in the cable, that can cause high return loss. You might have patch cord mishandling, right? So, for example, maybe they're not using the wire managers and the patch cords are getting kinked. Your service loops are too tight. Again, remember that can cause an inductive loop. And believe it or not, wet locations can also cause a return loss issue. And then probably the least most common issue that you can come across that's going to cause return loss is bad cabling. Again, 42 years in the industry, and I've literally only seen 2 projects that had defective cable from the manufacturer. Manufacturers go to great extents to make sure that their cables meet their parameters. and each batch cable has a lot number to it. So they want to make sure that those cables are good going out. Right. Since YTS Garcia brought up alien crosstalk testing, let's talk about that as well too. Alien crosstalk testing. It's also sometimes called 6-around-1 testing. It is not required to be done during the install. Okay, it's not required by the standards at all. The beautiful thing is, and by the way, I'm only aware of one manufacturer that that makes an alien crosstalk tester, and I won't say who it is because I don't promote companies on my podcast, but you probably know who they are. So the alien crosstalk tester, it's 6-round-1 testing. So what you're going to do is you're going to pick what's called a victim pair, and it should be one of the longest runs on the floor. You're going to plug one end of the tester into that victim cable. You can take the other alien crosstalk tester and plug it into the port right next to it on the patch panel. You got these little port plugs. You're going to give them to your little apprentice. You can tell them, run like the wind, and they're going to go plug in the other end of that cable. And you're going to test the 6 cables that surround that, right? 6 cables that surround that. By the way, Fluke has a really good video on this. If you go to the YouTube, type in field alien crosstalk cabling, you will find a great 9-minute video on crosstalk testing. But I will forewarn you, it's a video made by a sales engineer. A sales engineer. Somebody very smart trying to sell you something, right? That's exactly right. And so what you're really doing, and here's what happens. A lot of times, some people will tell you, some customers will tell you, if those who have said that they want alien crosstalk testing done, that they want a percentage of the job done, right? They want 10% alien crosstalk tested, 5% alien crosstalk tested. Alien crosstalk testing happens after all your other testing. So this is an additional step. And this is why you always want to use good quality components. Again, you could probably think of the manufacturers off the top of your head. There's four or five of them that I would consider really good manufacturers that you probably won't ever have a problem with. And they're not going to require alien crosstalk testing because their stuff has been tested thoroughly inside and out. But sometimes what happens is customers go to Bixie conferences just like we do, just like professional cablers do. And they sit in those free training events that the manufacturers put on. And they'll have somebody up there saying, hey, we have this new alien crosstalk tester. So now you can alien crosstalk test your cables so it doesn't interfere with any, so your cable plant works. Oh, I didn't actually define what alien crosstalk testing was, did I? Let's do that real quick. Alien crosstalk testing is how much one cable interferes with another cable as it's going down the cable pathway. Okay, that's called alien crosstalk testing. So when you do that testing, you have to do that in addition to your regular testing. So if you have 100 cable, now listen up, I'm going to throw some math at you. If you have a 100 cable project and the customer wants 10% alien crosstalk testing done, 10% alien crosstalk testing done on 100 cables, you are testing 60 cables. 60 cables. Because you got to test the 6 around 10 victim cables. That's a lot of time. So if you're an estimator on a project, you better make sure that you estimate that extra time in there. If you're a project manager, you're creating the material budgets and the scheduling. You better make sure that you schedule some time, extra time in the testing for that alien crosstalk testing. You also need to probably obtain an alien crosstalk tester somewhere. Yeah, I seriously doubt that your company has one. Now, you could probably go to Rent Telco and rent one or buy one from Fluke, but that's going to cost you money. But that's an extra step as a project manager that you need to go through. If you're a technician in the field and the customer asks you to do alien crosstalk testing, you may need training on that. Again, go watch that Fluke video, that YouTube video that they have. Right? And also remember, this is going to be in addition to the testing that you've done in your on top of your other testing. So it adds to the job everywhere else. Someone says they still can't hear me. I've got the audio on, testing 1, 2, 3. Yeah, it's coming across everywhere. I'm not sure what it's doing. So let's see. Shotzi says my sound is off. Huh. That's weird because it shows that it is on. Huh. There you go. Lee Renfro's in the house. He says vertical cable patch cords for the win. Vertical cable does make some good patch cords. All righty. 8 servants in the house. What about core ups with water still in the conduit and underground water, even after you shop vacked it out? Yeah. You really need to blow out those conduits, and you need to make sure that conduit is dry, because even if you're using outside plant cable, if it's sitting in that water can still get it in there. So there you go. All righty. So it looks to me like I have fixed my audio problem. That's good. Anybody have any other questions? We are at 6:28. I got 2 minutes left. What types of environments would want this type of testing? Anthony, I really wish I could answer that question because I have yet to ever have a customer request alien crosstalk testing, right? I've never had a customer request it. Maybe I should pose that question to Fluke or because Fluke's the only one that makes the alien crosstalk tester right now, I think. I'll have to ask them because I got some contacts over there. I would think if I had to take a guess, probably like a data center or maybe a call center, right? Where you got lots and lots and lots of cabling all put together. So why do we not test single mode fiber with encircled flux? Encircled flux. Huh. That's a great question. That one's actually outside of my realm. Lee Renfro's in the house. Maybe Lee could answer that one. Lee, if you're still here, why do we not test single mode fiber with encircled flux? I don't know that answer off the top of my head. I'd have to actually research. I don't know it off the top of my head. So there we go. Some mega data centers will do it themselves to test their own designs. Okay, that makes sense. There's a lot of data centers. I was actually in Virginia this week in the area of Virginia where there's a ton of data centers. I should have asked those companies while I was testing. So there you go. Any other questions before we kill this show? Because I am at 6:29. We got 1 minute before. So yeah, water under conduit is going to be a big problem. There's my 6:30. And circle flux lines up the light to the core. Yeah. All righty. There we go. All right, everybody. We are at 6:30. I've got a thunderstorm raging out there. I'm dancing with the devil right now because if we get a power fluctuation, my internet router is going to go down. It's just going to lose everything. So until next week, remember, knowledge is power. And also, wear your PPE.